Are you ready to bring the routing process to the next level? We can do it by using Layer 3 hardware offloading in Router OS 7. In this video, I will go over the different approaches to perform the routing process. The traditional way by using the device's CPU, and the new way by using IP switching or Layer 3 hardware offloading. Welcome to the network trip. Performance. But what exactly is this thing of Layer 3 hardware offloading? So when we talk about Layer 3 hardware offloading, basically we are talking about accelerating and optimizing the routing process. Now, instead of using the device's CPU, it's going to use a specialized chip that is in most of the new models of Mikrotik devices. So we're going to talk about which models will be able to offer this new feature in Router OS 7. In traditional software-based routing, basically everything is handled by the device's CPU. So now that's completely different, and we are going to see the difference in our lab. So we're going to have two different scenarios, the first one using the traditional approach, the next one using Layer 3 hardware offloading. And then we're going to compare those two technologies and which one is going to offer the greatest performance. In general, when we are using Layer 3 hardware offloading, we're going to have two big benefits. The first one, improved performance. So we're going to increase the routing speed. We'll be able to get what is called wire speed. So that means that you have an interface that is giving you a connection of 1 gigabit per second, you will be able to get that. You get 10 gigabit per second, you will be able to reach the speed on your physical interface. And that's only accomplished if we're using Layer 3 hardware offloading. And obviously the second advantage is scalability. So now you can have routers handling 5 gigs, 10 gigs, 20 gigs of traffic and more, because Layer 3 hardware offloading is going to be performing that routing process at the chip level. Now it comes the question, which models are going to support these features? So basically, most of the CRS 300 series, 500 series will support that. And also all the CCRs from the 2000 series, like the 2116 or the 2216. In these two tables that you see now on the screen, we can see some of those models, what is the different features that those devices will support, the number of entries they will allow, because that is going to change depending on the specific model. So here you can see some of the CRS 300 and 500 series. So you can see that we have here the switch chip model. We have the number of IPv4 routes. We can go from something like 16,000 up to 240,000. We can have a bunch of NAT entry rules. So you can see with some devices it's a little bit more than 2,000, but we can get up to 4,000 NAT entries. So basically the idea here is that we are going to have different interfaces. Those interfaces will be connected to a switch chip, and then we're going to have the device's CPU somewhere else. But basically all the IP routing process is going to happen at that level, at the chip or hardware level. So basically the CPU is still going to process all the different services that are running, but then it's going to send a copy of the routing table, NAT entries, to that switch chip, and then when we have traffic that is coming from the interfaces that belong or are connected to the switch chip, then this is going to perform the routing process. So we're going to see this in action just in a bit. If you want to get the specific models that are supporting this feature now that you are watching this video, you can go to this link that basically is the help.mikrotik.com website. So the docs section, and then here you can simply go to bridging and switching, and then you'll find this section for Layer 3 hardware offloading. Then you browse on the different menu options. Here you'll find one that is L3 hardware feature support. Then if we go there, you're going to get here all the different features that are supported, and then underneath that you're going to get the tables with the different models, different features that are supported. But if you go to the second table here, you can see that basically all the 300 and 500 series with those switch chip models, they will support most of the features. And At the bottom of the page, we're going to get the 2000 series, that basically the 2116 and the 2216. So now let's go to the action and let's see how this is going to work, and then we'll be able to compare different approaches. So now we're going to see this feature in action. To complete this lab, I'm going to use physical devices because we need to use the switch chip, and that is possible only on a physical device. So let's start analyzing the topology. We're going to test what is going to happen if we use the traditional approach of performing the routing process using the device's CPU, and then we are going to go step by step over the configuration of layer 3 hardware offloading. So let's go to the topology to analyze what we are going to be working on. So we can see here now that we have two routers. So I have a CCR 2004, I have a CRS 309. They are just two regular routers. Even though that this is a CRS that is working as a router, as a layer 3 device. And then here at the top, I have an RB411 that basically is simulating a client. So in this case, this is an RB411, but that can be a computer, that can be a server, so basically any end device. So now when we have more than one router, so we need a mechanism to exchange the routing information. And that can be via static routes, or that can be via ospf or BGP or RIP. So in this case, I have ospf running. So between those two devices here, we have ospf running, and they are able to exchange the routing information. So that means that this CCR 2004 is able to reach that IP address in that end device, the 10.100.100.2. And here between the CCR 2004 and the CRS 309, I have a VLAN, actually the VLAN 50, that is using the network 10.50.50.0/24. And we have the IP.1 on the CCR, the IP.2 on the SFP+1 on that CRS 309. And then we have the network 10.100.100.0/24 that basically is providing the connectivity to that end device, the RB411. And in this case, this can be like a CPE, a device that you have installed in your customer's location. So at this point, still I'm not using the VLAN 100, so I have this IP directly on the SFP+2. Later, once we configure the IP switching feature, we are going to move that into a VLAN interface. So let's see what we have now. We are going to inject some traffic from this CCR 2004. We are going to send traffic to that device by using a tool in routeros that is called the traffic generator, that basically is going to simulate actual traffic going from this router to the end device. So initially I'm going to send 500 megabits per second. If we are using the device's CPU in that CRS 309, we're going to see that this is going to be pretty high, pretty close to 100%. But once we implement the layer 3 hardware offloading feature, our goal is to reach 10 gigabits per second and having a CPU usage between 1 to 5%. That means that all the IP routing process is going to happen at the chip level without using the device's CPU. So let's see what we have now in that CCR 2004, CRS 309, and that RB411. So we're going to start with the router at the bottom, the CCR 2004. So if I come here, IP addresses, we can see that I have an IP 10.50.50.1 on VLAN 50 that basically is just a VLAN interface that is created on SFP+1. And additionally, I have ospf running. So if I go to routing, ospf instances, you will see here that I have an instance, I have the backbone area, and I have enabled ospf on that VLAN 50 interface. So basically that's everything that I have here in this CCR 2004. Then the CRS 309, so the device has the interface +1 connected to the router, to a CCR. The +2 is connected to the client, in this case the 411. At this point, I don't have any bridges. This is basically acting as a router, like the traditional routing configuration that we have performed in the past. So we have one IP on VLAN 50, we have another IP on the SFP plus 2 interface, and also I have ospf running on this device. So I have the instance, the area, and interface templates. Remember, if you are not familiar with ospf, I have a full series, ospf from 0 to hero, here at the channel. Check the link above. So now I have ospf here, and if I check the neighbors, so we're going to see that we have a neighbor adjacency between the CRS 309 and that CCR 2004. And then we have the 411 that is just a client. This is a regular client, and the interface SFP plus 1 has the IP 10.100.102 that basically facing this CRS 309. And I have a default route. I don't need to ospf here because this is a client's device. And then from here I'm able to ping the CR 2004. You can see we have IP connectivity. And if I go with a trace route, we're going to see that the first hop is going to be the CRS 309. The next hop is the CCR 2004. That means that this CRS is working as a router, a layer 3 device, not like a switch. So now what we need to simulate is traffic. And we're going to send traffic from this device to the client by using a tool that is called traffic generator. So let's go back to the CCR 2004. If I go here to tools, traffic generator, basically this tool in routeros allows to create different packet templates. Then we're going to create streams, and we'll be able to inject traffic, and that traffic is going to have actual packets with all the different headers for the MAC header, the IP header, the layer 4 header, and then the device that is receiving those packets will be able to perform the routing process over those. I'm going to include a video about the traffic generator tool here in the channel to go with very specific details about this awesome feature that we have available in this operating system. So if I come here to packet templates, so you see that now I have a packet template. This is a UDP53. So this is just a name. You see that it's going to have 3 different headers: the MAC header, IP header, the UDP header. And this is going to be using the interface VLAN 50 because we need to send the traffic out of the VLAN 50 interface. And the destination MAC is going to be the MAC of the CRS 309. And then the IP is going to be the destination of the client, that in this case is going to be 10.100.100.2, and the gateway is going to be the CRS 309. So basically we're simply creating a packet that is simulating how packet from real traffic will look like. And then on the layer 4 header, we are going to send this to the port 53. Now, okay, we have this template, and then we need to create what is called streams. So if I come here to streams, so basically here we can define different properties in that stream, like the bandwidth that we're going to use. For example, this one we're going to be using 500 megabits per second, and using that packet template. That means that we're going to have a stream that is going to consume 500 megabits per second. And also I have created another one that is for 10 gigabits per second, also using the same packet template. So now that I have that ready, I can simply start injecting traffic. So if I come now to this device and I check the VLAN 50, you can see that this is basically idle. There is no traffic going out of that VLAN 50. So I'm going to start generating some traffic generator, start. I pick that stream, UDP 500, start. And now this CCR 2004 is going to start injecting 500 megabits per second. And that is going to have this IP as the destination. So basically those packets will come to the CRS. The CRS is going to perform the routing process using the CPU, and then those packets will be sent to that client. But let's see what is going to happen in that device with the CPU usage, because now it's not going to be using the switch chip. So let's come to the CRS 309. So if I check the CPU, you can see that I'm using about 73%, 64%, 69%. So you can see here, This is receiving the traffic on VLAN 50 and then is sending the traffic to the RB 4011. So this is using the CPU. We are limited. It's basically impossible to reach wire speed because once we get around 1 gigabit per second, the CPU is going to be in 100%. And even though that these interfaces have a maximum speed of 10 gigabits per second, we won't be able to get that with real traffic. So let's analyze how we're going to go with the configuration process. So I'm going to stop this the generation of the traffic. So I will simply come back to traffic generator, stop. And now this is going to stop sending the traffic. If I go back to the switch, you can see that the CPU now is just 1% because it's just the Winbox traffic that is going to that device. So how are we going to go from that traditional approach to the layer 3 hardware offloading feature? And basically we're going to follow this process here on the screen. So first of all, we need to create a bridge interface. So before doing that, also my recommendation is to connect your device, the device that you're using to configure that CRS, to one port that is going to be out of the bridge. So in that case, we are preventing to lose the access to the configuration of the device. So now we'll come to this CRS 309, and the step number 1 is to create one bridge. And this is important because in all those CRSs, we must have only one bridge. If we create more than one bridge, then only one bridge is going to be using the switch chip. So I'm going to create a bridge. So let's call it simply bridge 1, and then we click OK. So that means that this step number 1 has been completed. The next step, add bridge ports. So we check the diagram. So basically here we have two interfaces. We have SFP plus 1 and we have SFP plus 2. So we need to add those two bridge ports to the bridge 1 that we have just created. So I will come back to that device. And basically I will go here to ports and I will add SFP plus 1, and also I'm gonna add SFP plus 2. The next step, this is also quite important. We need to create the VLAN table. We need to define tag ports and we need to define on tag ports. If we go back to the topology, we can see here that we need to build that VLAN table. This device is connected to the CCR 2004 using VLAN 50. So we need to have an entry in that VLAN table for VLAN 50. And we need to add all the interfaces that will send the traffic, including the VLAN header. And that is SFP plus 1, because all the traffic that is going to the CCR 2004 will be using the VLAN header. And also we need to add the bridge interface, because initially we need to provide access to the CPU to that, but later we're going to enable layer 3 hardware offloading, and actually we're not going to use the CPU, but still we need to simulate that because we're going to be performing the routing process. And that is going to be required, and then router is going to send a copy of that forwarding table to the switch chip to be able to perform that forwarding process. And then we have the VLAN 100. So you can see here that this traffic here is going to be on tag. So that means that this client is simply going to send frames, it's going to receive frames without a VLAN header, and that's why I'm adding the SFP plus 2 under the on tag section. And basically we are just adding a tag, the bridge interface itself. So remember, if you are going to be using layer 3 hardware offloading, you must add the bridge interface to the tag section for every VLAN or network that you need to be performing the routing process. If I don't add that bridge to the tag section, basically that VLAN 100 won't be able to perform routing in that device. So now that we have cleared that process, we're going to go back to the CRS and we're going to configure that table. and that is here under VLANs. We're going to add an entry. So the first one is 50. Remember, we're going to give access to the CPU, bridge 1. And also this traffic here is going to live with a VLAN header. So we need to add SFP plus 1 under the tag section. And then for the next one, we need the VLAN 100. Again, we must add a bridge to the tag section, but now the traffic going to the client is going to be without a VLAN header. So this is going to be on the on tag. And in this case, this is SFP plus 2. Additionally, we need to go to ports. And under this SFP plus 2, we are going to add the PVID. And this is going to be the port VLAN identifier that is also going to be 100. So now we have completed the next step in the process. Now we have ready the VLAN table. The step number 4, we need to add the VLAN interfaces and IP addresses. So this is also important because we are going to use something that is called VLAN filtering. And basically, we don't need to have IPs on physical interfaces. All the IPs will be on VLAN interfaces. So currently, you can see that I have VLAN 50. If I come here to interfaces and then VLAN, I have the VLAN 50 that is talking to a CCR 2004. So I need to move that VLAN to the bridge itself. So all the VLAN interfaces will be created on the bridge interface, not on top of the physical interfaces. And then I need the next VLAN 100 that is also going to be on the bridge. So basically the idea here is that all the VLANs that we have added to the VLAN table will have a virtual interface, and the parent is going to be the bridge itself. We're going to add also the IP addresses to those interfaces. So we'll come to IP addresses, and now you can see that the VLAN 50 already have the IP, but the client's network is on SFP plus 2. So now this is not going to be there, it's going to be on VLAN 100. So all the IPs will be on VLAN interfaces, not on physical interfaces. So once we have completed that step, we are ready to go to the next one. And that is the configuration of the ospf or static routing. So in this case, I have two routers, so we need a mechanism to exchange routing information. If you only have one router, this step is optional because you don't need ospf or static routing if you only have connected networks. And now we need to check the ospf process. So routing ospf, I have an instance, so it's going to remain the same. Areas, I have the backbone area, but now on interface templates, we are going to be running ospf on VLAN 50. So here we are going to wait for a neighbor adjacency, but also we want to advertise the network that is on VLAN 100, but here we are not expecting neighbors. So I will set this as passive. So if I go to neighbors, I have a full adjacency, and that means that ospf is working. So now we have completed the 5th step. And finally, we simply need to enable VLAN filtering. And to do that, we simply need to go to bridge, and then to the bridge tab, the first one on the left. We double click on the bridge, and then we go to VLAN, and we're going to enable VLAN filtering. And here in this PVID, we're going to set a value that is unused, something that is not in your network diagram. Let's say something like 999. And OK. And also we'll go to ports, and if we have a port that has a PVID of 1, we can change that value to something different as well. So now we are going to get disconnected from the CRS for a second, but then we need to access that device again. And now you can see that I have recovered the access to the device. I will come here to the SFP plus 1, and I will set this value to something random. So the PVID, we won't have any PVID with 1. This is just a security best practice. It's not mandatory, but it's a good practice. Now if I go to VLANs, you will see here that we have under current tag for VLAN 50 the bridge itself and the +1 interface, and for VLAN 100 we have the bridge itself and on tag the +2 interface. So basically VLAN filtering is working, but still this device is not going to be using the chip for the routing process. We need to complete the last step. We need to enable layer 3 hardware offloading. So before completing that step, if I go to IP routes, you see here that I have those entries, but they are DAC. This means dynamic, active, and connected. So let's see what happened after enabling layer 3 hardware offloading. How we're going to do that? Simply by going to the switch menu, and then here you will pick the switch chip. In this case, this is the switch 1, and you see here the model Marble 98DX 8208. So if I double click on that, I go a little bit down, so you will see this option, layer 3 hardware offloading. I will simply check that option, OK. And now, after enabling that feature, you can see here that now I got an additional flag, and that is for layer 3 hardware offloading. So it means that those entries now have been copied to the switch chip, and when this device is going to receive packets, it's going to perform the routing process just at the chip level without going to the device's CPU. That's a great advantage. And now we are ready to repeat the test that we have performed before. So now we'll come back to the CCR 2004 tool, traffic generator, stream, and I will pick the one for 500 megabits per second. I will go to traffic generator, start. I'm going to pick the stream for UDP 500 megabits per second. So we're going to see here, this is sending 500 megabits per second out of the VLAN 50. And if I come back to the switch, you can see that the CPU usage is 1% because all that traffic is not going to the CPU. If I go to the interfaces, we are going to see that this traffic is there. So you can see here we have the TX. We're going to move this column here to the left just to have full visibility over that. So you can see here we have the VLAN 50 and 100. They are not showing anything because everything happening at the chip level. So you see the traffic is coming in SFP +1 and is leaving out of SFP +2. And the CPU usage is just 1%. So now let's increase the amount of traffic. So let's go back to the CCR 2004. We're going to stop this, and we're going to go with the second stream. So it's going to be sending 10,000 megabits per second. That is equal to 10 gigabits per second. So now start, and we're going to pick the second stream. And if we go to the interfaces, now we can see that this CCR 2004 is sending almost 10 gigabits per second to that 4011, but it's sending that to the next hop, that in this case is the CRS 309. And let's see what the CPU usage in that CRS 309. So if I go to the device, so we can see that this is receiving the traffic on the +1 and sending that out of +2, almost 10 gigabits per second. But in this case, the CPU usage is just 2%. So if I come here to System Resources, we're going to see here the CPU load is between 1 to 0%. So basically everything is happening at the chip level, and we can validate that by going to the routing table, but you see that this is hardware offloaded. So basically this CRS-39 is getting packets going to the IP 10.100.102. It's checking the routing table, but this is going to happen at the chip level, and then it's going to deliver those packets to that device on the path. And this is how we are going to take advantage of this feature in Router OS 7. At the end, the idea is to improve the performance, to increase the scalability, and to offer a better experience to our users. So I hope that this video has been informative for you, and I hope to see you on the next one. Thank you.